In this episode, we will talk about what is dark energy. Let's enjoy it! At least 73% of the universe is dark energy. For understanding what dark energy is, we have to analyze the concept of vacuum from the perspective of quantum field theory. Quantum field theory is the unification between special relativity and quantum mechanics. But first, what is vacuum? In a coffee shop, for example, the space surrounding people is not a vacuum, because it is full of air.
The basket is empty.
Not exactly, Jason. From the physics perspective, the basket has air inside it, then it is not completely empty. Then we cannot claim that there is a vacuum inside the basket. Have you ever wondered why the cabinet of a plane is pressurized? The air is indeed a fluid. It has weight and it generates pressure over us. The higher we fly, the lower the pressure will be because there is less air. Still, the planes do not fly through the absolute vacuum. Indeed, the air is not different to the water. Both mediums are fluids. The only difference is their density and composition. An astronaut in the space will be surrounded by nothing. In other words, he or she will be surrounded by vacuum. But even the vacuum has energy. Quantum field theory demonstrated that the vacuum is very active. It generates and destroys particles permanently. If the vacuum has energy, then it also interacts gravitationally. The vacuum energy then appears inside the Einstein's equations as a positive cosmological constant. It acts as a negative pressure, pushing away the universe. The cosmological constant has an observationally small value. With such a small value, the universe still expands in an accelerated way. Then the galaxies separate from each other faster and faster at each instant. This is a process which doesn't seem to stop. The accelerated expansion of the universe was discovered in 1998 by two different research teams. In the past, Hubble and Lemaitre had already discovered that the universe expands. By then, however, nobody suspected that such expansion was accelerated. Then, by knowing that the universe accelerates, scientists proceeded to calculate the theoretical value of the cosmological constant. By using techniques of quantum field theory, they found a value larger than the observed one by 120 orders of magnitude. But what does it mean, 120 orders of magnitude failure? It is a complete disaster. It would be as terrible as predicting that your weight is not 70 kilograms, but rather a huge number. But how they did calculate the vacuum energy? That's something that we will explain in future episodes. For the moment, we can visualize the following situation. Imagine a ball looking for the most stable position, namely its ground state. Quantum mechanics, however, forbids us to know simultaneously the position and momentum of the ball. This means that the ball cannot stay without motion in its ground state. It has energy associated to it. In summary, quantum field's ground state has energy. This energy helps the universe to have an accelerated expansion. In future episodes, we will explain how to solve the discrepancy between the theoretical calculations and the observation. If you liked this video, please give us a like, share the link, and subscribe to the channel. You can also send us comments to the email address appearing on the screen. More videos are coming.